guys. So thanks, Troy. Great introduction. As Troy said, I'm going to talk about the TSC510 and TSC710, which we just launched last quarter. So without further ado, quick intro to what I'll talk about today is all things TSC510 and 710. I'll do a high-level overview of both, and then I'll talk about some of the shared hardware features. And then I'll go into Android fun. So I think two words that have never been said together, Android and fun. But this is updates around the Android OS because we are moving for most of our mobile devices to Android. So I'll go into a little bit of information about why we chose that operating system. And then from there, we do have some custom and updates and apps that will allow our users to enhance their field productivity. So I'll go into those, and then I'll close out with data plan and Q&A. So I always like to kick off with this slide, and this is our history of our Trimble survey controllers. So some of you may remember all or just some of this timeline. In fact, at Dimensions this year, we had a display with every survey controller listed here, and that was pretty fun to see folks look at that and talk about what they've used in the past. So Trimble has been in this market for 30 years, and I think this speaks to our history of longevity and of innovation. You know, we see the operating systems evolve and the communication has evolved, but our focus on incremental and breakthrough improvements has really never wavered. So going into TSC5, TSC510, the one thing that you'll notice about the 510 is the form factor is exactly the same. So it looks the same on the outside, but the hardware or the guts has been completely upgraded from a hardware perspective. There is nothing on the inside that is the same as the TSC5. In the TSC510, we have increased memory and storage. It's very powerful. We're using a Ferrari of a Qualcomm SoC system on a chip, and this is going to be about a 3 times faster processor than is in the TSC5. From a weight standpoint, it's going to be really similar to the 5, and then this is still Android, where we have an Android 14 OS. This gives the user access to Play Store, Google Maps, Gmail, etc. And then this is IP68, which is an upgrade from the TSC5, which was IP65. And this has NFC or near field communication as well. From the one thing I did want to go over is the device bracket and pole clamp. This is exactly the same as a TSC5. There's no need to upgrade. There's no need to get a new one because the form factor is the same. And because we've had really good feedback on this bracket, we saw no need to make any changes to this. Moving on to some of the high-level updates on the TSC7. So we'll kick off with the smaller bezel around the display. We minimize the screen's frame and for a more immersive experience. And this actually seems like it's something really simple that we could do, but the bezel is where all the cell antennas are routed, and a 5G cell modem has 4 antennas. So there's a lot of RF considerations and a lot of antenna routing that has to be done on these devices. It's pretty complicated. And one of the biggest changes is the OS. So the TSC7 is a Windows 10 operating system, and the 710 is launched with Android 14. We did have a reshaped neck and bodies, mimicking a little bit the 510 because we have that gripability around the neck, and that got a lot of positive feedback. This is about 1/3 of a pound lighter than the TSC7, and if you're in the field all day, that weight differential does matter. The keyboard layout is really similar to the TSC5 in that the keys are well spaced. It's really tactile feedback. It's really easy to use even when wearing gloves. And then USB charging port is USB-C, so only one port, and that is USB-C. Now, when you flip this around, this is again a 5G, and so the SIM the SIM is at the top. or the module rather, is at the top. And then this does have near field communication. And unlike the TSC7, this has a battery layout, which is very similar to the TSC510. So we have two internal lithium-ion batteries. These are not external. They cannot be removed like the TSC7. They're not hot swappable. What we did add is the ability to add an internal battery, and this is optional, and this should double the battery life. One thing I do want to point out is that this is a completely new bracket and pole clamp. And because the form factor has changed between the TSC7 and the TSC710, the TSC7 bracket won't work on the 710. So this does have a quick release pin position, which is configurable for right or left hand use. And then the other thing I want to mention is the pole clamp mount can remain on the pole, which is kind of nice. All right, moving into shared features of the 510 and the 710. Some of the shared hardware features, again, this is a really powerful processor. We choose our processor based on what we see as a longevity with the roadmap. We work really closely with Qualcomm. We know that these devices are going to be in the field for a long time. We want to make sure that we're going to get processor support for, up to 5, 6, 7, 10 years. And so we do work closely with Qualcomm on this. We actually chose a processor which is designed for rugged devices, so less battery drain, and you won't see as much heat generated. A lot of testing and a lot of work goes into choosing a processor. So 8 gigs of memory for larger files and 128 of storage. This doubled between the TSC5 and the 510. Again, from a usability standpoint and an ergonomic standpoint, narrow neck for easier gripability, and then a lightweight, as lightweight as we possibly can make this to reduce strain and fatigue. All right, so moving on to the keyboard features. I already covered this, so I won't go into much detail here, but there is a wide range of special characters and function keys. Anybody who's used the 510 or 5 or 7 know that this is a landscape orientation. The other thing that we do that is not like a consumer device is that our screen is readable in really bright sunlight. And then also we do have 3 different modes, which the user can choose in the quick start menu. And so we can do a stylus, a finger, or a glove mode as well. Okay, both the 510 and the 710. Can you guys still see me, hear me?
Yes, we can still hear you and see you.
Okay, I just got a pop-up that said there's something wrong with content sharing. Okay,
No, we can still see for now.
Okay. All right, so moving on to the modularity that these devices have with the Empower modules. Both devices still retain Empower bays. The TSC510, 1 bay, and the 710, 1 bay, or sorry, 2 bays. And these will support all active and future Empower modules that are currently in development right now. Super easy to install these Empower modules. There is a screwdriver with the stylus, so you don't have to carry a special tool. There are no Empower covers needed, and then the software is pre-installed in the Trimble OS image. You can also go to the Google Play Store and update the Empower modules as well. All right, so from key hardware features, looking at the comms, this is a bit of a word salad, but the few things I want to point out here is that both devices are AT&T and Verizon certified. So AT&T and Verizon carrier certs are have the most stringent standards globally. We know if our devices are certified on those networks that they will work on any network globally. Both devices utilize a nano SIM card. And again, TSC710 is 5G and 510 is LTE. Wi-Fi and Bluetooth, suffice it to say that we have the most updated standards in both of these devices. And then we've added near field communication to both these devices. And part of this is future proofing. When we start to engineer and develop a device, sometimes it can be 3 or 4 years from the time that we kick off the project until this is launched. So we really wanted to make sure that we are really thoughtful about how to future-proof these devices. So we could do pairing from a receiver or an instrument, for example, in the future with NFC. Also, there is the potential that you could use NFC if there's any kind of multi-factor authentication that's required, which seems to be getting more and more commonplace. The GNSS is integrated on the cell modem, and this does have a 16 megapixel rear-facing autofocus camera. Okay, from the input-output ports, there is one port, and this is USB-C. So in the pack-out, you have a USB-C to USB-C cable. This is both charging and data. This is a quick charge, power delivery 2.0 compliant. And so you'll have a full charge on both devices in about 2.5 hours, 50% charge in an hour and a half. And we do have a universal charger, which is backward compatible with the TSC5, will work with the 510, 710, and the newly launched T110 tablet. All of our certifications are done. USB-C to Hirose, yes, that is being worked on. Frankly, that should have been launched a while ago, but that now has gone to the folks that make the instruments. And they are doing some testing there. So I would say we're close to getting the USB-C to Hirose. That's definitely in the works. Okay. So there is a universal charger that we have developed. And again, this is really to make things easier for our users. Instead of having a separate charger for each device, we have one universal charger, which will work on all devices. This charger has also, again, every device we have this charger has been certified with that device. So we do recommend using this charger when possible. All right, battery configuration. So again, the biggest difference, one of the biggest difference between the TSC7 and the TSC710 is going from an external battery to those internal batteries. So both of these devices have a very similar battery layout. And there are 2 internal sealed lithium ion battery cells at the bottom of each device. There's also the Li-35, which is an optional user replaceable battery pack, and this will nearly double the battery life. I was a product manager of the TSC5. I started right after it launched, so I got to be a part of the display fallout fun. So I've used a TSC5 since I've been at Trimble for about 3 years, and I can get 36 hours of battery life using an Li-35, the supplemental battery. So we do a lot of testing on the internal batteries. When we look at a robotic total station with radio module workflow, TSC510 gets around 16 hours, a little bit more than that, and the 710, 9 hours. GNSS with RTK corrections, the 510, 18 hours, and the 710, 11.5 hours. I will caveat this by saying your battery life is going to be affected by display settings. So if you have display brightness at 100% instead of 70%, that's going to eat up more battery. Connectivity, if you're running Wi-Fi, Bluetooth, and cell, that's going to eat up more battery. What kind of data processing, your ambient temperature, that will all impact battery life. A lot of these tests that we did some in the office, we did some outside. I'm very happy with these battery life results, but it's gonna depend on your workflow. It's gonna depend on the temperature. So just keep that in mind as well. Optional removable battery. So I was always saying this is the Li35. It is compatible. We have a new supplemental battery. It is compatible with the 510, 710, and is backwards compatible with the TSC5. If you have an older version of the Li35 that you used with the TSC5, this is not forward compatible. So there's a ridge grip design on the sides, and it doesn't allow the older battery to be installed in a 510 or 710. This does have a USB-C port for convenient charging, and it can be charged in the host device, and you never have to remove it. If you do remove it, there is a nice LED status indicator, which will indicate the charge level, and then power and comms interface in the host device. So in the host device, you'll see 2 battery fuel gauges, and the supplemental battery will drain before the internal battery. All right, moving on to environmental, we spend a lot of time ensuring that these devices are as rugged as possible. So I want to go into some of our environmental tests and considerations when designing these devices. Temperature rating. So the 510 and 710 have an operating temperature of negative 30 C to plus 60 C. This is not like a consumer device. You know, you put your iPhone in the car and you get that heat warning. These will operate in some pretty harsh temperature conditions. We use industrial rated hardware components to ensure the ruggedness that's required for our users. And this can have a startup temperature of negative 20 C, and then a charge temperature 0 C to 45 C. And this is just, the charge temperature is just battery chemistry at this point. We can't change those physics. So this will work in a wide range of temperature, from the coldest of the cold to the hottest of the hot. So mill standard, there's a lot on this slide, but what I really want to talk about here is that we follow the U.S. Department of Defense test method standard. And what this is, it's applied to military applications, and obviously in our case, commercial applications. And what we want to do is duplicate the life cycle of the environmental stress that our equipment may face, and then evaluate the performance. So we test a ton of different criteria. We're going to look at altitude. We're going to look at humidity, transit drop, which I'll come back to, solar exposure, salt spray, vibration, fluid contamination. You know, these devices have to make sure that they can withstand, you know, if you've got sunscreen or insect repellent or, you know, Red Bull or whatever, and then corrosion resistance as well. So when we look at all the drop tests that we do, it's a very robust test plan. So we'll do 26 drops from 4 feet onto plywood and concrete, and we'll do it at different temperatures. And we also do a ball drop on the display, and so we want to mimic this device potentially falling on a rock or falling on the concrete, you know, or whatever may happen. So we do these drop tests from the very first engineering sample that we have all the way to production units. And we usually have 3 or 4 stage gates with 3 or 4 design samples in there. We test this internally, and we also test this externally. The other thing I want to mention is we don't do these tests on separate devices. One device will go through every test criteria. We want to make sure, for example, that if this device is dropped on a rock, it will still retain its water and dust ingress. Okay, and then finally for environmental, that we have is an IP68. So the 6 is the dust ingress, and this is 8 hours with blowing talcum powder. And from a water standpoint, the 8 is the water ingress. And so this is immersion up to 1 meter and at a depth, up to 1 meter depth for 2 hours. All right. moving on to Android Fun. I got a lot of questions at Dimensions. Why Android? And so Android is really optimized for mobile devices, and it's going to give you a much better battery life. We see this when we look at the TSC7, which you're lucky to get 5 to 7 hours in the field, versus a 710, where depending on the workflow, you can go 9 to 11 hours. It does offer a smaller footprint, so you're going to have enhanced performance, and again, going back to that better efficiency when it comes to a battery life. From a Google Synergy standpoint, Trimble, our devices are all GMS certified, which I think the best way I can describe that is we're essentially a Google OEM. And so this allows our customers to access all the Google suite of products and apps via the Play Store. So kind of contrary to why Android, why not Windows? And the biggest limitation with Windows, well, there are a couple limitations, is Windows 11 does not support display sizes that are under 9 inches. And so the TSC710, the 7, is the 7-inch display. And so the UI is not optimized for anything that is under 9 inches. Now, they will let you put Windows 11 with an annual waiver on anything less than 9 inches, but that waiver is not guaranteed, and Windows 11 is not optimized. And so given that we know that our users keep their devices, there are still so many TSC3s in the field right now. For a decade, sometimes we thought that we did not want to take that risk, that we wouldn't get a waiver, or that they would, that we know that the Windows 11 is not optimized for a 7-inch device. Windows is really power hungry, and it's not optimized for mobile devices. And then it's better suited really for desktop applications. The other, there are some really nice features on Windows, such as, that are Windows specific, TeamViewer and Microsoft Teams, which were specific to Windows for a long time. Those are all available on Android right now. I'll go into a little bit about the OS and some of the enhanced security that we do to ensure that our devices are as secure as possible. I think there is an assumption that Windows is more secure than Android, which isn't the case. And then we also do some advanced security as well. So just an overview of the operating system. We'll launch with Android 14. It is upgradable. The Trimble OS is GMS certified. It means that Google has certified our software and hardware combination, and we provide standardized enterprise-grade features and expertise. We have an enterprise-level agreement with Google, and part of that agreement requires us to provide OS security updates no older than 90 days. So these are going to be deployed over the air always. And we do it over Wi-Fi. So Trimble Installation Manager will continue to be used to update our software like Access. And from how many versions of Android can we get? This is actually determined by the processor. So again, when I talked about the processor roadmap and ensuring that we choose not only a robust processor, but a processor that we know has a longer roadmap. This is because the processor will determine how long we can update to the versions of Android. All right, OS product development. So we take the standard Android Google image, and then we Trimbleize it. As an OEM, we can do this. So we'll add specific applications. Security patches will always come from Google and Qualcomm, so come from the software and the hardware. Bug fixes and firmware updates, any driver updates, and then any kind of custom hardware support. So some additional security that we do is we use a threat modeling to assess our components and responsibilities. We do this to create security expectations, and then that allows us to prioritize our resources. The other thing that we do is penetration testing. So this is conducted by a third party, and this will cover our hardware and firmware before we release a product and any OS revision. So if we're going from Android 14 to Android 16, for example, we'll go through penetration tests. Every stage of our product development stage gate process, we will also go through a penetration test, and we cannot move to the next stage unless that test is passed. We have an independent cybersecurity team which will review these results and give their thumbs up or thumbs down, or a list of action items that need to be required before we can move on to the next stage gate. So obviously, we're not going to share the results publicly of the penetration test findings, but we do have certificates available if anybody's interested. Every single high and critical finding is addressed. And then medium findings are discussed with our engineering and product team and cyber team, and we'll figure out case by case if those need to be addressed or not. So best practices: install your OS update as soon as possible after it's pushed to the device. You will get increasingly annoying messages that this OS is available, the new update is available, new update is available, and then we'll push it after 5 days of nagging. Any component is available through Google Play, and then ensure the OS is updated before troubleshooting or servicing. A lot of times we can do a lot of fixes through OS updates. Okay, I'm going to try to be super quick here because I'm running out of time. I want to go over some Android productivity features that we have that y'all may not know about. The first is Android Quick Share, and what this is it's a Google proprietary sharing method. It uses Wi-Fi and Bluetooth direct connection for fast file sharing. You can send files to multiple nearby devices. And you can send files, Android devices, Chromebooks, and some Windows. This is the only way we share files between data collectors and our laptops in the office. It's super quick. It's really cool. I'm not going to, in an effort of time, I'm not going to show this clip, but takes 30 seconds to share a JXL from the controller to the office laptop, and then from the office PC back to the controller. It's really slick. You need to make sure that you have Quick Share enabled on your device, and then that the host device also has Quick Share. Trimble Data Manager. So this is a proprietary Trimble app that we developed, and all of our Android devices our survey controllers are launching with this. What this is it's an Android-based file explorer, and it offers a Windows-like file structure. And we built this for TSC5 and any Android survey controllers. It has to be running Android 13 or above, and it's designed for direct data transfer. This is available on the Google Play and Store. Can be updated on Google Play, and then also in the most recent Trimble OS image. Why did we do this? We did this because anybody who has tried to transfer files on an Android device knows that the native Android file transfer system is really clunky, and it's a big pain in the butt. So we really want to address the pain points that we were hearing about in the field, and then we ourselves were experiencing as well. Like we would have a USB stick that we knew was that was the correct configuration, and Android would say, hey, this USB drive is corrupted. Is just the native Android file explorer is very inefficient. And then we saw a lot of difficulty. So we wanted to eliminate those data transfer problems, and we wanted to have this ready when we pushed our new survey controllers to the market, which we did. So some of the features, you can transfer files reliably and easy. This is, you can navigate with ease. You have quick access to essential folders, direct connection to select Trimble application folders. So you can easily use this app. You can go into your project file. Everything is right there. Additional functionality, we have search, and one of our market acceptance team loves this app. They're like, we want split screen, so we were able to give them split screen and drag and drop. We also have favorite, cut, paste, move, delete, rename details, and the latest version that we just released will also have a recycle folder, because once you delete a file, it's gone. So we did add that recycle folder as well. Real quick, Android apps. So from a mobile device management, where you can manage a fleet of devices, this is native to Android. You also have Find My Device, which individual users can activate, and this will remotely locate, lock, and wipe devices as well. And the Android Enterprise will facilitate remote management, security policies as well. I can confirm that Find My Device works. I have a 14-year-old who sometimes like to take my device and see what he can get into. So I found it under his bed. Microsoft, okay. Other apps that we talked about previously, Microsoft Teams is compatible with Android devices. Support is limited to the last 4 versions of Android, which shouldn't be a problem. And then there are certain hardware requirements for certain user scenarios, but all of our devices meet those hardware requirements. Lots of questions around TeamViewer. TeamViewer is supported on Android. This provides remote IT support and remote device management. This does require specific apps such as TeamViewer Remote Control and TeamViewer Host, and it will work on Android devices running an OS of 5 or above, which I don't even know if those still exist in the world. If you have trouble, we do have a step-by-step kind of user doc of how to use TeamViewer on Android devices. So reach out to me, or I can maybe push that in the GDN if there's enough interest. And then finally, I just want to cover this really briefly, data subscription plan. So we kicked off a multi-network SIM subscription plan when we launched the newest round of survey controllers. What this is it's 3 networks on 1 physical SIM card. In the US, it's the big 3, AT&T, T-Mobile, and Verizon. We have 2 plans available, 1 gigabyte per month or 2 gigabyte per month. And this is a one-time annual subscription, so you're not paying monthly. We see that our survey controllers use between 1 and 2 gigabytes a month, which is pretty typical data usage. Again, this is a physical SIM. You have packs of 25 that are available on the iStore. Subscriptions can be purchased in Virtual Warehouse, and this is available on all legacy and new controllers that are cell-enabled. This has been field tested for over a year. We use this at the offsite at Dimensions in 2024. Anybody on the test team this is the only cell SIM card that they have. We really wanted to make sure that this was a robust solution before pushing it out to the market. And we've been really pleased with this. So just customer benefits, you get seamless network switching for continuous connectivity. You're going to have a wider coverage area. You're going to reduce the dependency on a single network provider. And you'll have single SIM solution eliminates the need for multiple network SIMs. And then cost efficiency from a data device management standpoint. All right, and with that, I'm 6 seconds over. So you guys can, I will I will let Troy take it from there. And if there are questions I can answer, happy to do so. I saw some pop up, but was not able to address everything. But my email's up here, so feel free to reach out to me.